Hello students, welcome back to Mathematics for Everyone. In this video, we shall take an example to clarify Cartesian product of real number with itself, and then we shall take a representation of a relation by arrow diagram, and domain and range of a relation. So first of all, we take example. For example, let P is equal to, let P is 2, 3, then find P into P into P. Solution, we have P is equal to 2, 3, then Cartesian product of P with P is 2, 3 into 2, 3, which will give you 2, 2, 2, 3, then 3, 2, 3, 3. Then we take Cartesian product of P and P with P. Now, P into P is equal to 2, 2, 2, 3, 3, 2, 3, 3, Cartesian product with 2, 3. So we get 2, 2, 2, 2, 3, 2, then 3, 2, 2, 3, 3, 2. Next, 2, 2, 3, 2, 3, 3, 3, 2, 3, 3, 3, 3, 3. So this is Cartesian product of triple P. When we take next example, second question, if A is 1, 2, 3, B is 2, 6, C is 3, 4, 6, then find number 1, A minus Cartesian product of A minus B and A minus C. Second, Cartesian product of A union B and B intersection C. Therefore, solution, we have A is equal to, set A is 1, 2, 3, B is 2, 6, C is 3, 4, 6. First part, first of all we find A minus B, as we have already done. A minus B is a set of all those elements of A which are not in B. So there is element 1 and 3 which are not in B. Similarly, we find A minus C. A minus C is a set of all those elements of A which are not in C. So there is 1 and 2. So Cartesian product of A minus B and A minus C is 1, 3, 1, 2. So this will give you 1, 1, 1, 2, 3, 1, 3, 2. Second part, to find A union B and Cartesian product of A union B and B intersection C. A union B, we take A union B 1, 2, 3, 6. Then B intersection C is common in B and C is 6. Therefore, Cartesian product of A union B and B intersection C is equal to 1, 2, 3, 6 and 6. So this is ordered pairs 1, 6, 2, 6, 3, 6, 6, 6. So this is Cartesian product of A union B and B intersection C. Then we take next question. Third question. Find P and Q if P cross Q, Cartesian product of P and Q is 1, 3, 1, 5, 2, 7, 3, 7. Solution, we have Cartesian product of P and Q is 1, 3, 1, 5, 2, 7, 3, 7. Therefore, P is the set of first elements, which is 1, 2, 3. And Q is set of second elements, which is 3, 5, 7. So that's all. Then we take a relation. We define what's the relation. Let P and Q are two non-empty sets. Let P and Q are two non-empty sets. A relation from P to Q denoted by capital R is a subset of Cartesian product of P and Q, which implies R is a subset of Cartesian product of P and Q. Therefore, if R is a relation from P to Q, then R is equal to ordered pair XY such that X belongs to P and Y belongs to Q. Therefore, if XY belongs to Earth, then X is related to Y and is written as X or Y. In particular, if P is equal to Q, then subsets of Cartesian product of P and P are called relation from set P to the set P, or it is written as a relation on set P. Let us take example. For example, number 1, let P is 1, 2, 3, 4, 5, 6, 7, 8, 9. Then let R is a relation is square of. Then R is 4, 2. Because 4 is the square of 2. 9, 3. Because 9 is the square of 3. Second example, let P is 2, 4, 6, 8. Let R is a relation is greater than. Therefore, R is equal to 4, 2. Why? Because 4 is greater than 2. Then 6, 2. Why? Because 6 is greater than 2. 8, 2. 8 is greater than 2. 6, 4. Because 6 is greater than 4. 8, 4. 8 is greater than 4. And 8, 6. Why? Because 8 is greater than 6. Then representation of relation by arrow diagram. Representation of a relation by arrow diagram. Let P is 2, 4, 6, 8. 2, 4, 6, 8. And Q is ABC. So then let R is 2A, 4A, 6B, 8C. So we shall represent by arrows as this is P, 2, 4, 6, 8. This is Q. This is Q, A, B, C. Now 2 is related to A, 4 is related to A, 6 is related to B, and 8 is related to C. So in this way we can denote this relation 2A, 4A, 6B, 8C by an arrow diagram. Then number of elements of relations. Number of elements of relation. Let P and Q are two finite sets. Let P and Q are two finite sets such that number of elements in P is X, number of elements in Q is Y. Then number of elements in Cartesian product of P and Q is 2 raised power xy. Since R is a subset of Cartesian product of P and Q, therefore number of elements in R is 2 raised power xy. Then we define domain, range and codomain of a relation. Domain of a relation. Let R is a relation from P to Q. Let R is a relation from P to Q. Then domain of R is all those elements of X such that X, Y belongs to R. That means domain is the set of first elements of R. Means domain of R is the set of first elements of ordered pairs of R. Then we take range of relation. Let R is the relation from P to Q, then range of R is all elements of Y such that X, Y belongs to R. This means range of R is the set of second elements of R. Then codomain of relation. Let R is a relation from P to Q. Then Q is called codomain of relation R. So that's all. In the next video, we shall take the questions based on domain, range and codomain of relation, and also we shall take types of relation. So please Don't forget to share, like, comment and subscribe to Mathematics for Everyone. So see you in the next video. Thank you.